Have you ever stepped onto a subway train or maybe a tram, feeling that familiar rumble as it whisks you across the city and just, well, trusted that it's safe? We rely on these incredible public transport systems every single day, but have you ever really stopped to think about the invisible layers of scrutiny? The assurance that makes that trust possible. It's far beyond just the drivers or the tracks we see. It's about a meticulous, often unsung process happening behind the scenes.
It's true. And it isn't just about good intentions either. What underpins that trust is a highly specialized, really rigorous process. It brings an outside, unbiased perspective to deeply scrutinize every single aspect of a public transport system's safety. It's called independent safety assessment, or IS for short. Think of it as the ultimate safety guardian, quietly working away.
Right. And that's exactly our mission for this deep dive. We're going to pull back the curtain on independent safety assessment. We'll explore what it is precisely, why it's absolutely vital in our increasingly complex world, how these independent experts actually conduct their work, and the profound benefits it brings, not just to the transport projects themselves, but ultimately to you, the passenger. So let's dive in. Okay, so why is ISA, this independent assessment, why is it so incredibly crucial now? What's changed?
Well, what's fascinating here is how much public transport systems, especially railways and urban guided transport like metros, how much they fundamentally change. They're no longer just mechanical systems. They're incredibly complex, deeply networked, increasingly software driven. I mean, they integrate a vast array of cutting edge technologies. We're talking about systems where, a single line of code could, in theory, impact millions of people.
Wow. And that level of complexity, I imagine, means just relying on internal teams or the older safety checks. Well, it just doesn't cut it anymore. It sounds like trying to check a supercomputer with, I don't know, a basic toolkit. The sheer scale and how interconnected everything is. It demands something far more robust, right? Almost forensic.
Exactly. And that raises a critical challenge. How do you ensure there's absolutely no internal bias? When a company designs or builds a system, their own teams naturally have a vested interest. You need an objective, independent viewpoint. A set of fresh eyes that aren't influenced by project timelines or maybe budget pressures. This third-party assessment ensures nothing gets overlooked, providing truly impartial verification that, frankly, internal checks just can't guarantee.
Okay, so if we strip away all the technical jargon for a second, what is independent safety assessment at its very core?
At its heart, independent safety assessment is about one critical question. Does this train, or this new signaling system, or even just a specific component, does it truly meet every single safety rule? And is it ready to safely do what it's built for? It's a rigorous, methodical process of analysis. It leads to a definitive judgment on whether the system is fit for purpose and crucially safe to operate.
And it's not just someone showing up and having a look around, right? It's built on a very specific, established framework.
Oh, absolutely. This assessment is built upon foundational industry principles. Imagine building a house. The V model is like a methodical blueprint. Every design decision on one side of the V has a corresponding inspection and testing phase on the other. It guarantees you verify each step before moving forward. And then you have safety cases. These are essentially the system's complete safety biography. It's a meticulously documented, undeniable argument backed by, reams of evidence, proving that every bolt, every line of code, every single process contributes to a genuinely safe operation. And all of this is underpinned by robust quality management methods.
Okay, that makes sense. So who exactly is this independent safety assessor? What's their core responsibility in this whole ecosystem?
The independent safety assessor's primary role is to act as the ultimate safety auditor. They verify that the required level of safety and quality is met, and not just by one group, but by all the different parties involved in a project, from the manufacturer to the operator. Their goal is to ensure a safe implementation that aligns with stringent national and international safety standards.
But they're not the ones actually doing all the detailed verification and validation.
Yeah.
Like the hands-on nuts and bolts testing. That sounds like a different job.
You're spot on. Yeah, that's a common misconception. The supplier or the developer, they hold the main responsibility for those detailed verification and validation activities, the V&V. They provide the actual evidence of safety. The independent safety assessor, however, judges whether the supplier's V&V activities and their entire safety management organization, whether they've applied the correct processes and techniques. They're essentially assessing the assessor, making sure the homework was done right, if you like.
Yeah. Oh, okay. And what's the ultimate outcome of all this meticulous work? What does it all lead to in the end?
Well, it all culminates in that critical license to operate. The ultimate goal of ISA is to provide the safety authority, that's the governing body, with the necessary assurance. Enough assurance to grant permission for a systems operation. This license could be for the entire system, or sometimes just for specific modes of operation. But without that independent stamp of approval, that system likely isn't going anywhere near passengers.
That question of independence feels really crucial here. How do you truly guarantee that impartiality, especially when complex projects involve so many interconnected companies and teams?
That's a profoundly important point for objectivity, yeah. While an independent safety assessor might, in some rare cases, technically be part of the supplier or operator's larger parent organization, they must be totally structurally and functionally independent from the specific project team they're assessing. And perhaps even more importantly, their reporting line must go directly to the safety authority, not up through the project's internal management. This structural independence is absolutely key to their objectivity and credibility. It ensures their opinions are free from project pressures or constraints. It really protects the integrity of the entire process.
Got it. So we've explored the why and the what of ISA. Now, let's pull back the curtain a bit more on how this is actually done. What's the methodology these independent eyes apply?
Right. The methodology is pretty comprehensive, focusing on two main pillars: what is assessed and how it's assessed. On the what side, they're looking at everything from the top down. That means scrutinizing the overall system design and its safety goals, including the operator's initial criteria, their high-level safety requirements. They also review preliminary hazard and risk analyses to understand potential dangers right from the very start.
Okay, and they don't just look at the high-level plans. They dig into the supplier's internal workings too, right? Like their own rule books and how they manage quality.
Precisely. They scrutinize the supplier's entire setup, their quality management system. We're talking the quality plan, policies, procedures, how they organize, responsibilities, the codes and standards they apply, design and development processes, configuration management, how they trace requirements, production control, how they handle nonconformities, staff competence and training. Basically, making sure safety isn't just an afterthought, but baked into every step. They also evaluate the supplier's safety management system, how they organize for safety, their internal V&V structure, and critically, how they ensure independence for different safety integrity levels.
Safety integrity levels, SILs.
Yeah.
What exactly are those, again, briefly?
Great question. Safety integrity levels, or SILs, yeah. They're a crucial measure, like a numerical rating. It indicates how robust a specific safety function needs to be to prevent a certain type of failure. The higher the SIL, the more rigorous the development and testing required for that particular safety function. The assessor makes absolutely sure the right SILs are applied and properly adhered to.
Fascinating. Okay, so beyond the systems and the plans, what about the actual implementation of safety, the real-world process on the ground?
Right. That's where they really deep dive into the supplier's safety process implementation itself. This involves scrutinizing safety plans, procedures, the analysis tools they use, and critically, how they specify and trace every single safety requirement through the entire project lifecycle. They pore over test plans, test equipment specifications, test reports, V&V plans and reports, and the all-important final safety case. It's like forensic safety work, tracing every hazard identified, every risk analyzed, every mitigation measure specified and implemented during design and construction, right up to system validation and ensuring hazards are properly closed out.
Wow, that sounds like an immense amount of detail to cover. So how do these assessors actually gather all this information? What are their techniques?
They employ a range of proven techniques. It always starts with planning, preparing a detailed assessment plan. Then they conduct thorough audits and interviews with the supplier's quality and safety management teams and processes. A huge part of it is meticulous documentation review. Poring over critical documents like safety plans, concepts, hazard logs, design specs, test specifications, reports, safety cases. They're looking for completeness, validity, clarity, consistency, making sure it all adds up.
So a lot of, let's say, desk work, but also on-site verification, I imagine, seeing things in action.
Absolutely. Definitely boots on the ground. They perform test witnessing and site inspections throughout different project phases. That includes factory acceptance tests of individual components, site installation inspections, commissioning tests, and even trial runs of the full system. They're there, watching, checking. They also perform detailed inspections of the safety cases and all that supporting evidence documentation. And importantly, they raise observations and findings. They don't just point fingers, they communicate interactively, aiming for solutions, providing recommendations, and sharing lessons learned. This often takes the form of a continuous project accompanying safety certification approach, rather than just a single check at the end.
And this whole methodology, it sounds like it's applicable to a really wide range of public transport scenarios, not just, say, one specific type of train.
That's a key strength. Yeah, this methodology is proven effective for a wide range of situations. Combinations of classical and new technologies, systems with drivers and modern driverless operations, and even highly complex systems involving multiple networked, software-driven components. It's also applicable for generic product and application approvals, which can then form a foundation for specific projects. And it enables something called cross-acceptance, where possible.
Cross-acceptance, can you quickly explain what that is? Sounds useful.
Yeah, it is. Think of it as a clever efficiency tool. If a certain safety component or maybe a process has already been rigorously assessed and certified as safe in one approved system, cross-acceptance might allow it to be used in a new similar project without repeating the entire assessment from scratch. Obviously, you check it's appropriate, but it saves time and resources while maintaining those high safety standards. It's a true win-win for progress and safety.
That's a good segue, actually, thinking about the entire life cycle of a system. Does independent safety assessment just happen at the very end, like a final stamp of approval before things go live?
No, not at all. That's a common misunderstanding. ISA is integrated directly into the system's life cycle. It typically follows that V-model approach we mentioned earlier. From the initial concept all the way through design, build, test, operation, and even eventual decommissioning. The assessor can, and ideally should, be involved in every single phase right from the very beginning.
Okay, so it's not a one-time thing at the end, but more like a continuous process with checkpoints, almost like getting building permits along the way for a construction project.
That's a perfect analogy, yes. For complex systems, planning for intermediate assessment and approval milestones is absolutely crucial. These interim go-ahead gates are vital. For example, a project might not be allowed to proceed to detailed design until the functional and safety requirements have been reviewed and accepted after an assessment milestone. Think of milestones like completion of system requirements, subsystem design complete, subsystem installation checked, subsystem integration and trial run successful, and finally, system acceptance for commercial operation. It prevents problems from snowballing, It allows for early intervention if something isn't right.
Right. And what happens when you have a massive project with lots of different pieces? You mentioned rolling stock, signaling, communication stations, all these different subsystems. How does ISA handle that?
Yeah, that's where the layered complexity really comes in. Complex projects involve many subsystems, and each often undergoes its own parallel design, development, testing, and assessment cycle. Independent safety assessment refines the general lifecycle model to address both the overall system aspects and these subsystem-specific issues. All those individual subsystem safety cases, all that evidence, then eventually integrate upwards into the overarching system-level safety case. It paints the complete safety picture. It's a bit like building a complex Lego set. Each piece needs to be checked and verified before it fits perfectly into the whole structure.
Makes sense. And who's talking to whom throughout all these phases? How do all these players, the operator, the supplier, the assessor, the authority, how do they interact?
There are usually clear collaborative roles and interfaces defined between the operator, the supplier, the independent safety assessor, and the safety authority at each phase of the project lifecycle. From concept definition right through operation, maintenance, and eventually decommissioning. The ISA works in close cooperation with both the supplier providing feedback and the safety authority providing assurance. They act as that crucial objective link for safety assurance throughout.
And all this assessment must lead to mountains of documentation, right?
Yeah.
How does that all fit together logically?
It absolutely does generate significant documentation, but there is a specific hierarchy. It usually starts with a top-down approach at the beginning for system-level requirements, defining what the entire system needs to achieve safely. But then, as subsystems are developed, there's a bottom-up approach for collecting all the detailed subsystem safety evidence, test results, analyses, verification reports. This evidence then forms that integrated system-level safety case, which is the comprehensive argument for safety we talked about. It tells the complete story of the system's safety from every angle.
So just to circle back on that point, it really is the supplier doing the bulk of the heavy lifting on verification and validation, the detailed checks. But the independent assessor is constantly checking their homework, ensuring it's done correctly and thoroughly enough.
Precisely. That sums it up well. The supplier conducts extensive V&V activities at both the overall system and subsystem levels, especially for safety-critical areas like signaling and train control. The independent safety assessor then reviews and assesses these activities and the resulting safety evidence. They ensure not just that the work was done, but that it was done right according to the plan and to the required standard.
Okay. So to kind of bring it all home here, it sounds like independent safety assessment is this absolutely critical, maybe almost invisible backbone for our public transport systems, especially as they get more and more sophisticated. What are the big, impactful takeaways for someone listening, maybe an engineering student or someone starting their career, trying to understand its true value?
Well, the benefits are really profound, and they genuinely extend to everyone involved. I think the true genius of ISA isn't just about catching mistakes, though that's important. It's that its very presence often forces suppliers to elevate their own internal safety game. It encourages their engineers to become their own toughest critics,
Yeah.
proactively identifying and mitigating risks long before the independent assessor even steps in. It's a fundamental shift towards self-policing excellence, which significantly reduces project risks right from the start.
That's interesting. So it's not just a check at the end, it's actually a catalyst for better internal practices throughout. And these assessors, they must bring a lot of accumulated wisdom to the table, too.
Absolutely. Beyond just the checks, these assessors become repositories of hard-won wisdom. They're like the collective memory of countless transport safety challenges. They bring insights and solutions from past projects to help prevent future failures, sometimes even before anyone on the current project realizes a similar problem could emerge. This provides operators with immense confidence, independent of any potential supplier constraints or blind spots.
And for the authorities, the safety regulators, it helps them manage their workload, too, right? It allows them to focus their resources more strategically.
That's exactly right. It allows responsible safety authorities to focus their limited resources effectively on their core legal responsibilities, knowing a thorough, independent assessment has already been done by experts. Plus, there are other ripple effects. Potential marketing advantages for projects that have successfully gone through this rigorous process, reduced liability insurance perhaps, and the power of those cross-acceptance principles we mentioned to accelerate innovation safely. It truly is a win-win situation for everyone involved and, most importantly, for public safety.
It really is incredible to think about all that goes into it. So next time you step onto a train or a metro, maybe take a moment to consider the invisible layers of scrutiny and assurance, like independent safety assessment, that silently underpin its journey. What does this deep dive into safety assessment make you wonder about the future of transport? And maybe your own role, perhaps as an engineer, a professional, or just an enthusiast, in shaping its continued safety and innovation.